Hello, and welcome to this edition of EMS Now Up Close. I am Eric Miskell with EMS Now, and today I get to interview Tomide Adesanmi. He's the CEO of CircuitMind out of England. Tomide was introduced to me recently based on a new solution he's brought into the industry that I find very fascinating. So I thought it would be great to spend some time with him and allow him to present that to the audience. So Tomide, welcome. Thank you for taking the time to speak with me today.
Thank you very much, Eric. Glad to be here. Big fan of your podcast, and great to be here with your audience.
Good. Well, let's begin. You have an interesting story, and why don't you start there? Kind of introduce yourself, kind of your background, and your journey in starting CircuitMind.
Yeah, gladly. So I'm Tomide. I'm the co-founder and CEO of CircuitMind, and CircuitMind is an industry leader in building AI and automation solutions for the electronics industry. Specifically, now we're building AI design tools for EMS companies. So before CircuitMind, I was actually an electronic systems engineer. So I used to develop high integrity augmented reality display systems for jet fighter pilots at a company called BAE Systems. So one of my projects, I was kind of just looking back on my career, 5 years in, and thinking that most of the projects I've worked on took years, took tens of millions of dollars. And I looked back and thought, I spent so much time on a lot of routine, tedious tasks that did not necessarily need my creativity or experience. And consequently, I didn't do the kind of job that a lot of electronics engineers go into the industry looking to try to do, which is like the sort of Tony Stark creative invention stuff. Yeah. So, at that time, I started looking into solutions that could help me accelerate the electronics design process, reduce risk and the errors that you make that have you having to redesign things, and develop the best possible kind of designs that I could do. And that led me to meeting my co-founder, who's an algorithm developer. So he has two masters and a PhD in algorithm design, and we formed CircuitMind. That was about 5 years ago now. Since then, we've worked with lots of different engineering companies, including Fuji, Trek. We've raised millions of dollars from the likes of Google and Silicon Valley investors, and it's just been an incredible journey, Eric.
Yeah. No, thank you for that, because I always like telling the stories of the industry, and this is a good one, I find. So tell me, for the benefit of the audience, simply put, what is it that your solution strives to do?
Exactly. So our solution strives to help you automate the circuit design process. So just kind of if you step back and think about the way software is developed, where you can come up with an idea, you can put your requirements down, write some code and compile, and you get a piece of software that you can put into the hands of consumers and then iterate on it. We all know that hardware is harder than that. You can't do that. So our solution, we're building a solution that helps you do that same thing with hardware. Specify your requirements as an architecture, specify requirements on it and what you care about, like cost, size, power. I'll tell you about that in a second. Yep. Click a button and generate your starting design.
Okay. So in doing so, what are the main issues that you're seeking to solve?
It's a great question. And I will try to focus, the problems that we've seen in the EMS space. I'll focus my answer on the problems that we've seen in the EMS space. So what we found talking to a lot of electronics manufacturing service VPs and engineering directors is that they're seeing a lot of fierce competition from other EMSs and ODMs that's eroding their business growth and their profitability. And so there's a new type of strategy that the most successful EMSs are employing or introducing in the market, which is about building this cradle to grave strategy, where they build a strategic relationship with the customer from the moment that customer has an idea, and leverage a product design and development team to help that customer develop the product before taking it to manufacturing. So this is this cradle to grave strategy that everybody is trying to employ. The problem with the cradle to grave strategy, though, is that it's quite difficult. It's quite difficult to respond to a customer's request for a proposal quickly and precisely, unless you do weeks of work fleshing out things like the bill of material cost, what functionality you can deliver, what performance you can deliver, et cetera, et cetera. So you're doing weeks of work before you even get the program or project going. There's also a massive engineering skill shortage, and which makes it hard to execute on those development projects. And then customers are being incredibly demanding. They are putting pressure on you to reduce development cycles, at the same time develop high quality design products. So this kind of cradle to grave strategy is now imposing more and more requirements on the EMS themselves. So what we do is we help to try to solve this problem by helping those businesses take the requirements from a customer during that proposal phase, discovery phase, still with a customer, put it in the platform, generate 10 different optimized solutions in 10 minutes, accelerate the development from that initial architecture to schematic very, very quickly in seconds, and then navigate all the development issues around helping one engineer to become much more productive and reducing risk, supply chain risk, and so on in that development process.
Okay. Listen, as I'm hearing you discuss it and explain it, of course, we've talked before, so it makes sense to me. But for the benefit of our audience, why don't you give us a teaser, kind of a demonstration of how this works? And I think the audience will appreciate seeing that.
Absolutely. So what you're about to see, so I'm going to show you just a brief sneak peek teaser of how you can use the platform. What you're about to see is going from our idea on architecture at that point when you're still even just discussing it in a proposal to a schematic and a bill of materials in minutes. This is the workflow that you take. So this is an actual example of one of our customers who received a block diagram from very, very high level block diagram from one of their OEM customers. So this is the block diagram that says, these are all the functionalities I want in my design and how I want them connected to speak to each other. I want to minimize my bill of material cost. I want a small form factor, low power. I want to explore different architectures. I want to make sure I'm using, and the EMS is saying, we would make sure we're using preferred components. And we want to kind of do this exploration on also different microcontroller tool chains. So this is kind of a top level requirement. This should go into manufacturing maybe a year down the line, but you want to also develop this for this OEM customer. So what do? You'll go into the CircuitMind platform, even at the point of proposal, and start building the set of requirements with them. So just because this is a teaser, I've prepared some of the requirements, but this is how you do it. I'll just drag and drop. So you can create your block diagram. Anyone from your engineering lead to an engineer to even a business development person can go in there and just search for these component blocks that can make up an architecture. So I'm dragging and dropping an accelerometer now, and I'll drag and drop a gas sensor. So this is where, from the set of requirements that I just showed you, just drag and drop them and connect them together. And you don't need to do much more than this. You can also specify on each of these blocks lower level requirements that the customer might care about. So you might say something like, I want a specific number of axes, XYZ axis. And there are many, many more things that you can specify, like operating temperature range, resolutions, and so on. You can do that and even go as far as saying you want a specific manufacturer or even a part number. You can leave it as high as you want, or you can go as low as you want. And at this point, you can already just say, I've built my architecture, generate a schematic for me. You will build that set of requirements in less than 5 minutes. You click generate schematic, and you'll get a result in less than 10 minutes. But the good thing is you can actually generate multiple different design options. So you can go back to the input and say you want a cost optimized design, or and generate that. And it's going to run in parallel and generate a different design option as well. And you can do this with power optimization, size optimization, availability of components, and so on. And you can do, much more in the platform. There's way more in the platform, but this is just a teaser. And then I'll just show you an example of exploration of different solutions. Before this, I generated about 10 different solutions. Each took about 7 to 10 minutes. And I'll just show you how to compare all this. So when you finish generating your schematic, you can just, your different results, you can just compare them against each other. So this is 10 different BOM options compared against each other. You can see the total size, total cost, total power. So at the beginning of this proposal, you can already start to tell a customer that we can get you a design with that's $17, but the size, this is the form factor it can fit in, and the power consumption is a bit lower, and you can actually compare them against each other. But I can give you 32, but the size is a bit smaller, etc. So you can explore these different options against each other, and then when you're done with the exploration, you can go into each of the designs and then look at a starting set of schematics that your engineers can use for the detailed design process. So it's created a schematic, it's selected all the components, added pull-ups, pull-downs, decoupling capacitors, level translators, all the things needed for a functional design. You get your full bill of materials. You get all your procurement information, and we can actually plug into your procurement systems to collect pricing data, or we pull live pricing data from all the distributors. And then there's much more, including detailed verification checks to make sure you don't make any errors. And you can then export to your design tool to use that as a base to build the detailed design on top of. So this is just a way of going very, very quickly from a customer needs something to giving the customer a lot of confidence that you're the right person to go with because you already have a lot of options in front of them immediately. And then you can start your detailed design with this platform.
Wow. Great teaser, so to speak. Let me, Tomide, so without this tool, the normal process using conventional kind of processes takes how long?
Yeah, so it really depends based on your the design that you're trying to do. But I'll just explain it this way. So the conventional process from architecture to a complete design, it's about 1 to 6 weeks per iteration, but it takes 3 to 10 iterations to get to the final circuit design, right? And that's because of basically engineering processes and engineering changes and errors. So our aim is that 1 to 6 weeks, just really, really massively compress it. So that 1 to 6 weeks is the kind of big issue. And bear in mind that in between these iterations, you also have like 1 month of prototyping and testing in between each iteration. So this just expands the development cycle. So our aim at CircuitMind is really to make that iteration, that iteration, instead of 1 to 6 weeks, to be a week, days, etc., and do as much for you as we can. And I just want to say something, Eric. I'll just share my screen very quickly. That the designs that we ran while I was showing you the teaser are completed, and they took 2 minutes each. And so
my goodness,
full hardware design and your bill of materials. So I just wanted to show that just to close the loop.
Hey, and let's be very clear on what this is and what it is not. This is not actual board layout. That's what this gets input, and then that whole begins.
100%. So this is not board layout. So there are, if you can actually divide up that 1 to 6 weeks into 2 per iteration, into 2 parts. The first one is the sort of front end, like this sort of component selection and schematic capture, and then there's the back end, which is layout. The platform currently helps with that front end for a few reasons. The first reason is that's where you can really do true optimization of your design. That's where you get the better BOM cost, the better power consumption, the better performance of your product. While layout is more more closely, it's just more about speed and the time improvements. So we're really trying to focus on helping you get more optimized products by optimizing this front end of your development process.
And so as a result, then the people who are actually using this, a customer who's employing this is going to be more somebody who like you were in your career early on, right? An electrical engineer who's wanting to be Tony Stark and create the next great whiz bang product in their field.
Absolutely. So the different groups of customers that we have are professional electronics engineers, always professionals. In this case, we don't focus on, at this moment, we're
hobbyists,
not hobbyists or anything. So professional electronic engineers, hardware managers, some of whom have had, prior experience in doing electronics, engineering leads, and in some cases, business development managers, because they are in meetings with the customer, talking about proposals and just putting together block diagrams that easy to use and just generating bombs and saying, we can do $15 for you, but I don't know if we can do 17, right? Yeah. So those are the kind of groups of users we see.
Yeah. And that's both at an EMS company and an OEM.
100%. So EMS and OEMs, there are different use cases for both, but yes, we have OEM customers as well.
Okay. And then I noticed, obviously, when you showed the bombs there, it's generating a lot of the component selection piece. But you don't, in the US, we say, you don't have a dog in the race there, right? You're not advocating for one over the other. This is you're just pulling the available material based on the components, the different types, the different functionalities and everything, cost, price, right? So how does that work for you?
Yeah. No, that is very correct. We're not skewing the results for anybody. And we're a neutral entity here. We just want as much data as we can get. We get data from APIs that distributors and aggregators make available and manufacturers make available. And then we take that information live, and use it to generate a design. And we look for the best potential, based on the components in our that we've created, the best potential option. And just to give you an idea of how we're doing that, we're using mathematical algorithms that can look at quintillions of potential design options. And my algorithm engineers explained to me that the number quintillions, that means if you think about 100 Earths, all the grains of sand in those 100 Earths, that's how many combinations we're looking at. That's what quintillions means. It's hard to imagine, but an algorithm can do that. A person can't do that.
Right. In Texas, we say that's a lot. So, that's how that. Tell me though, as you're bringing this forth and doing that, are you seeing any resistance to the adoption of this, and how are you addressing those?
So early days we were, but not anymore, because it all depends on how you explain what you're doing to an engineer, and how you explain what you're doing to a company, and the value that you bring to those companies. There's a second thing that affects that has kind of shifted the scales. It's the timing. With things like ChatGPT and all these other things coming into people's personal lives, people are actually more willing to kind of adopt automation solutions. And so that has really helped. Now, we don't do anything like ChatGPT. This is not a probabilistic model or machine learning. This is algorithmic, mathematical. So basically mathematical algorithms that are deterministic and should always give you a correct answer, not guessing. So that's not what we do, but just the influx of automation tools in people's lives has made them more open to adopt these solutions. But if you create value for a customer, they'll find a way to start adopting. And if you explain things the right way to an engineer, that this is not, supposed to do design instead of you, it's a tool for you to get better designs faster. There's still parts of your design that it wouldn't do for you, like the most analog, most creative parts. That's where you become Tony Stark. people kind of start, warming up to the idea.
Yeah. And you mentioned at the very beginning when we started speaking here about the this also helps address kind of the HR challenges that the industry is facing and the lack of engineers, and even if we have enough engineers who are going into this field, right, and pursuing these types of jobs. So this seems like a great accelerator for those types of processes and industries.
Absolutely. I'm a bit concerned right now, because if you look at the rate at which people are graduating electronics engineering and going into software or investment banking or consultancy at McKinsey, it's alarming. If we continue this trend, then 20, 30 years from now, I mean, even 10 years from now, the industry is going to be completely bare in terms of skill and talent. So what we have to do is we have to train up people, give them the tools to just be much more productive. 5 years from now, 3 years from now, you need your engineer to look like what two engineers, to be able to do what two engineers used to do in the past, because there are just not enough people in the market to do. And there's a high demand now for electronics products. It's like renewables, CO2 capture, IoT designs, automotive, self-driving cars, all of that. It doesn't balance. The demand and supply doesn't balance. So you need tools now to help you bridge that gap.
Yeah. And as you said too, it's a tool that helps take away the mundane tasks that, of course, every job has to a degree, but to the degree that you can minimize that and allow people to get to the real exciting part that maybe intrigue them about the field. That's a great value add.
100%. That's our focus.
Yeah. No. I am very intrigued by your solution here, and also I also think about the potential of what you can build upon this, right, moving forward. And maybe that's a topic for another discussion someday. So because I wanted to accomplish an introduction of what you're doing, because I find it a great solution for the industry and what's happening now. So if people want to know more, learn more, come see you, Tomide, how do they do that?
Yes, so the two ways: you can either email me directly, tomide@circuitmind.io. So that's TOMIDE at circuitmind, CIRCUITMIND.io. Or you can go to circuitmind.io directly and just ask to get a demo of the platform. Someone will reach out to you or request access to the platform as well.
Okay. He's also on LinkedIn, by the way. That's I saw him there. And also where you're located is in London?
Yes, we're located in London, UK, and Boston, Massachusetts.
Okay.
So UK and US.
Okay, perfect. So just so that people know when they reach out, they can get kind of different piece. Tomide, this is fascinating. I love your solution. I love telling, like I said at the beginning, I like telling the stories of the new solutions, and yours is I find a fascinating one with great potential for the industry. So I commend you on your efforts to date, and I look forward to seeing what's still to come as we enter the new year.
Thank you very much, Eric. Appreciate it. Thank you very much for hosting me. And I would love to come back and discuss, some of the ideas that you had.
Yeah, well. I think we should do that. Absolutely, sir. Tomide, listen, and we're at the end of the year here, so I always wish everyone a happy holidays and a successful end to 2023.
Happy holidays, everyone.
Thank you.